The vanishing reason your next breath depends on water that's quietly disappearing into the Earth itself. And in 2020, satellite radar caught the Mariana Trench's floor dropping 8 inches in 12 months. Water and rock sliding straight down into the planet's molten interior. And nobody has found a way to stop it, or even fully explain where it's going. Every drop of water on Earth moves in a loop you were taught to trust, ocean to sky to river to tap, back to the sea forever. But 7 miles down in the deepest scar on the planet's surface, that loop has a leak. The Pacific Plate is diving beneath the Philippine Plate at the Mariana Trench, dragging seawater trapped in rock down with it, feeding it into the mantle like a drain swallowing a bathtub. Scientists thought the drain was slow. New measurements say it's opening faster than anyone modeled, and the ocean above you is already paying the price. In 2020, a team tracking the trench with satellite gravity data, the same tech NASA uses to weigh ice sheets, found the seafloor near Challenger Deep sinking at a rate that shouldn't be possible under current models. Nearly 8 inches a year in places and accelerating. That's not erosion. That's not settling. That's the crust itself being pulled downward, water and sediment vanishing into a subduction zone nearly 7 miles deep, the deepest point on the entire planet, deeper than Everest is tall, turned upside down. And here's the part that should unsettle you. The same physics pulling that seafloor down is the same physics compressing your blood right now. Pressure. At the bottom of the Mariana Trench, it's over 16,000 pounds per square inch, enough to crush a submarine like a soda can. Your body survives at 1 atmosphere. The trench operates at over 1,000 times that. The line between you and total annihilation is thinner than you think, and it's getting thinner every year the trench sinks deeper. Here's the twist researchers don't like to say out loud. This isn't unique to the Mariana Trench. It's happening at nearly every subduction zone on Earth all at once. And for decades, geologists assumed it was harmless, even helpful, a slow-release valve keeping the ocean from swelling too high. But new modeling out of the University of Southampton suggests the mantle may be swallowing water faster than volcanoes are returning it to the surface. If that's true, Earth's oceans aren't just being slowly drained. They've been draining for millions of years, and we only just noticed the drain was open. Here's what's actually happening 7 miles beneath the waves. As the Pacific Plate bends and dives beneath the Philippine Plate, its rock isn't dry, it's soaked, locked with seawater inside minerals like serpentinite, water trapped in stone for millions of years. As the plate plunges deeper, heat and pressure squeeze that water back out, deep inside the mantle wedge, sometimes over 400 miles down. That released water doesn't just disappear quietly. It lubricates fault lines, and it's now linked to some of the deepest, strangest earthquakes on Earth, quakes that shouldn't be physically possible at those depths, because rock that deep should be too hot and too compressed to fracture. In 2015, a magnitude 7.9 earthquake tore through the Sea of Okhotsk nearly 400 miles down, a depth where earthquakes shouldn't happen under old models. Scientists now believe dehydrating slabs, exactly like the one feeding the Mariana Trench, are the trigger. And the water itself. Researchers estimate the Mariana subduction zone alone may be carrying up to 3 times more water into the mantle than previously calculated. Water your ancestors' oceans once held at the surface, now locked kilometers inside the planet, possibly for good. Some models suggest that over the next billion years, enough seawater could be swallowed this way to lower global sea level noticeably. The ocean isn't static. It's being quietly rationed, one subduction zone at a time, and the counter started long before you were born. So what does that mean for you, standing on dry land thousands of miles from any trench? More than you'd think. The oceans regulate your climate, your rainfall, the air pressure in your lungs, the weather that decides whether your crops grow or your basement floods. A shrinking ocean, even by fractions of an inch over centuries, shifts currents, shifts storms, shifts everything downstream of that water cycle you were taught to trust as a kid. And it's not just water disappearing, it's structural. Every inch the Mariana seafloor sinks reshapes stress on faults across the entire Pacific Ring of Fire, the same ring responsible for roughly 90% of the world's earthquakes. You don't live near the trench, but you live on a planet where the trench's appetite never stops working. Here's the question no one's answered yet. If subduction zones have been quietly swallowing seawater for over 4 billion years, and no one detected the rate was accelerating until satellites caught it by accident in 2020, what else is happening beneath your feet right now, at a pace too slow to feel, too deep to see, that we simply haven't looked for yet? The trench has been sinking since before you existed. It won't stop because you noticed.